Welcome to Unit 8, Aquatic and Terrestrial Pollution, which you can imagine is a pretty large topic. So this is going to be broken up into, many lectures. So here we go. So before we talk about pollution, we need to know what kinds of pollution there are, more specifically, the difference between a point and a non-point pollution. So a point pollutant is where I can literally pinpoint where that pollutant is coming from. So very, very specifically, it's coming from that factory, whereas a non-point is actually more diffuse and harder to pinpoint. So perhaps it's coming from a farm, but like which farm? Perhaps it's coming runoff from streets. Maybe it's, eroding soil or whatever it may be. It's just really hard to say, like, this is where it's coming from. Whereas a point, you just point to it. That's it. Okay, you get it. So pollution affects everything, right? So our human impacts are affecting ecosystems. This is a massive topic. So I'm going to go through it. It feels a little haphazard, but I'm going to go for it. So before we actually talk about the effects of pollution on ecosystems, we have to remember range of tolerance. So remember that organisms are optimal at certain conditions. Some are more tolerant than others. They have a wider range of tolerance, where some has a very narrow range of tolerance, meaning that if they experience conditions outside of what they're good with, they can experience issues. So some sort of physiological issue, whatever that may be, reproductive issues, just stress in general, metabolic issues, whatever it may be. But then ultimately, if it's outside of the range of tolerance too much, then they die. So remember, you move, adapt, or die. And if you can't move, guess what's going to happen? So corals are an example of an organism that can't move, and they have a very narrow range of tolerance. And they have these zooxanthellae in their tissues that are symbiotic, and they really can't live without them. They can for a short amount of time, but they really do need them. And so when they're stressed out, whether they are experiencing whatever stressor may be, sedimentation, ocean warming and acidification, which we'll talk about in Unit 9, or any kind of pollution, those corals are going to expel their zooxanthellae, and they're going to lose their color. So we call that coral bleaching because they turn white. And that's okay for a little bit. So if the stressor is removed, the zooxanthellae come back. But if the stressor is constant, which is what's happening in our oceans, then that's trouble, and our corals are dying. So also in the ocean, a source of pollution are oil spills. So depending on how that oil is being transported from the source, that's where we're going to get our spills from. It can happen in the ocean via ship, if we're shipping it across the ocean, if there's a boat accident or something like that. And then across land, it can go across the pipeline. In the pipeline, something can break or leak, and it gets into the ground. And ultimately, what gets into the ground can get into our groundwater, and that's not good, because that's our source of drinking water, right? But also, just not good. And another source of an oil spill is from actual drilling. So whether it be on land or in the ocean and deep water drilling, there is definitely oil that is being lost at the source as it's coming out of the ground. So that can also be a source of an oil spill. Oil spills specifically really affect birds. When the oil gets on their feathers, it reduces their ability to insulate themselves. They can't fly. They eat it from preening, right? They put their beaks in it and ingest it, and other wildlife ingests it. So once the oil is in the ocean, you have a lot of marine organisms that are ingesting or taking up these oil, and then ultimately, getting into the food chain. Oil also reduces sunlight, so obviously it's going to limit photosynthesis. And so what are we going to do when the just kidding. I thought I knew what slide was next, but just kidding. I'm going to talk about specific oil spills. So there are two major oil spills you should definitely know about. The first one being the Exxon Valdez. It happened in the 1980s, and this was a tanker that I think it ran aground, and it spilled a lot of oil into Prince William Sound in Alaska. And so basically it just was a massive, massive problem, and just got into the plankton. And with the plankton, right, there goes the base of our food chain. There's just massive die-offs of other organisms. And so you can see on the left there, that's what the beaches look like. So just oil covering everything. And you can imagine all of the ingestion. Just massive cleanups happening. And honestly, there's still oil on those shores. Another major oil spill is the Deepwater Horizon or explosion or incident, or the BP oil spill. You can see that is hyperlinked. So anytime you see a hyperlink right there at the top, but you guys know what a hyperlink looks like, you can download the PowerPoint and click into it. Anyway, what happened in the Deepwater Horizon is there was a big methane bubble that basically escaped in the drilling process and just set the rig on fire. And so the pipe broke and oil just started coming out of the earth, and we had a really hard time containing it. And it just, really, really wiped out the ecosystem in the Gulf of Mexico. So obviously ecologically that's not good. But then if you think about how many people rely on the Gulf of Mexico for their living, fishing and shrimping, not to mention the tourism industry, right? Like people are going to the beaches. It had a huge economic impact also. So now we're going to talk about what happens when that oil spills. How do we fix it, or how do we try and fix it? And so, it depends on what kind of oil is being spilled. The temperature of the water, is it cooler or is it warmer? That's going to affect the viscosity of the oil. What kind of shoreline? Is it rocky like it was in Alaska? Is it sandy like it is in Texas? Right? So what do my beaches and my shorelines look like? That's going to affect how I actually go about cleaning up. We can use bacteria to break down oil. There are also just chemical agents. We can spray. So basically, you can disperse the oil so that it, goes out more. Remember, the solution to pollution is dilution, but not really. You can actually sponge it up. You can get it to flocculate or clump together and ultimately sink down, because if you don't see it, it's not a problem, right? They can burn the oil off the surface of the water. And then, of course, to contain the oil, booming is very effective. So you can see on the right, those are a series of booms containing an oil spill. And so once we contain it, we can skim or vacuum that oil off the top. Of course, we're not going to get all of it, but at least it can contain it and not cause it to disperse even more. Although those booms do get breached at times with wave and wind action, but at least the majority of the oil gets contained. So another pollutant that we are very concerned about are heavy metals. Mercury is a big one. But inorganic mercury, like elemental mercury, actually is not that toxic. What ends up becoming toxic is once it actually gets into the system, and like bacteria and other organisms, once metabolically convert it to methyl mercury, and methyl mercury is really toxic. It can cause all kinds of reproductive issues. Same with lead. Lead causes neurological issues, reproductive issues, cadmium, arsenic, right? All of these can cause cancer, right? So when we talk about pollution, our big effects are developmental, reproductive, neurological issues, and then of course cancer. Right, if you think about the effects of pollution, whether it be on wildlife or humans, those are our big ones. So once pollution gets into the ground or into the water, it can also get into our groundwater. Anything that happens on the surface ultimately percolates down into the groundwater and contaminates it. And so not only heavy metals, but also fertilizers, pesticides, which we'll talk about in a little bit. And why is that a problem? Because that's where our drinking water comes from. So if the pollution is in our drinking water, then ultimately we are going to get that in our systems. Groundwater is very difficult to remediate. The residence time is much longer. So while if pollution happens in surface water, ultimately it mixes in with some more fresh water or not fresh water, right? But some more unpolluted water, and ultimately will dilute, and the effects aren't so extreme. But in groundwater, it just stays there for so long. Recharge is very slow, and flow is very slow, and so groundwater is very hard to get rid of these kinds of pollutants. Yet another pollutant that we are concerned about is actually sediment. So it seems silly, right? Like, okay, like sediment's not a pollutant, but right, we learned about clear cutting and the removal of vegetation that holds that sediment into place. So with surface runoff is going to run off, via the watershed. It's going to end up into surface waters, and so that sedimentation has all kinds of issues, right? It decreases water clarity, which can decrease photosynthesis, right? So turbidity is increased, and that can clog up fish gills. But then also those sediments have nutrients adsorbed to them, and so the nutrient load actually increases. And great, more nutrients, but we'll actually learn about why that might not be a good thing. And that's while they're suspended, but eventually they end up settling out into the water, and so it actually it changes the bottom habitat, like the benthic habitat. And so those organisms that live on the bottom of surface water, their habitat is being destroyed. Also, it reduces water depth, right? And that can alter the flow. Not to mention any toxic materials that are on those sediments will accumulate at the bottom. So another pollutant is litter. And I want to specifically talk about plastics because plastics don't break down. They're forever. Other things might take a little longer to break down, but, plastics are designed to not break down. And so that's what they do. They persist. And so when things are not properly discarded, ultimately surface runoff brings them into the waterways. And so usually garbage will end up in the major ocean gyres. And so one that's very infamous is the Great Pacific Garbage Patch. And, people think of it like a big, massive garbage in the middle of the ocean, which it's not actually. It's much more diffuse, and it's deep. So, it's not super easy to clean up. And where you end up getting a collection is more at the coastlines. But, litter ends up in the ocean. What's the problem with that? Well, ultimately, plastics break up into smaller pieces of plastic and smaller and smaller and smaller, increasing surface area. And so I end up with these microplastics, and there are all kinds of chemicals in plastic that can leach into the water. And we're going to learn about BPAs and PCBs and the issues with those. Another thing is larger pieces of plastic can end up in the stomachs of all kinds of aquatic organisms and marine birds, causing, digestive issues and ultimately death. And then, people don't really think about it, but as garbage is floating from one country to the other, it can actually facilitate the spread of invasive species. You could have like a little, mussel clinging to this piece of plastic floating from, China that ends up on the other side of the world. And then we have an invasive mussel. So, that's definitely an issue as well. So oxygen depleting substances are basically anything that depletes oxygen. So it's some sort of biodegradable waste that bacteria can feed on. So those bacteria are using up the oxygen in the water to break down that waste. So maybe it's something like sewage or food waste or something like that that goes into the water, and ultimately bacteria are using it up, using oxygen up. And it causes a hypoxic condition where you have very low oxygen. So that's different than no oxygen, which is anoxic. So it really causes a depletion of oxygen, so a hypoxic condition. And so I love this diagram. If you look at it, you have this point of waste at the bottom. And if you look at the line of dissolved oxygen, you have a very high dissolved oxygen, and your biological oxygen demand, so the amount of oxygen that's needed by bacteria, is low. And then when you input those kinds of biodegradable waste into the system, those bacteria start to really deplete the oxygen as they're degrading that waste, or while they're metabolizing that waste. And so the oxygen actually ends up dropping, and my biological oxygen demand shoots up. So when oxygen is low, biological oxygen demand is high. And so it causes this oxygen sag, so they call it, because the oxygen levels drop and then come back up once the pollutant is more dispersed. Okay, so we're going to talk about endocrine disruptors, which are kind of crazy because endocrine disruptors are basically affect your endocrine system, obviously, right? So your hormones, they mimic natural hormones, they block the effects of hormones, or they can actually promote or inhibit your body's production of hormones. And so that has all kinds of consequences in both wildlife and human: cancer, reproductive issues, birth defects, immune function, your nervous system issues. And so these chemicals can really wreak havoc on the body, whether it be, wildlife or humans, like I said. Here you can see a list of what they call the dirty dozen. There's a hyperlink there that I suggest that you click on because it kind of goes into detail of each of those chemicals and what they do. BPAs, atrazine, lead, PFCs, which is in your cookware, glycol ethers, so paint solvents, so things that you're exposed to quite often. So, take a look at those so you can see what you are exposed to. So these hormone disrupting chemicals actually cause major issues in aquatic organisms, especially in vulnerable species. So you can see on the left you have these ambiguous genitalia. So there's a frog that has both testes and ovaries, which is not good for reproduction. So, that's not good. But anything that absorbs through the skin, any organism that absorbs through their skin is going to be affected more. They're more vulnerable. So remember that amphibians are an indicator species. So when we see these kinds of issues in amphibians, we know there's a problem. Also, it's causing intersex in fish. So, and this is caused by estrogenic endocrine disrupting chemicals. Basically, estrogen, disrupting their own hormones. And so where is estrogen coming from? Well, the sewage water that disperses into surface waters is not treated for pharmaceuticals. So when humans are taking birth control, it ends up going through their system and ultimately goes into surface waters. And it can, in certain concentrations, make male fish turn female. So you end up with an imbalance in sex within the species.